The intro to chapter 9 integrated 2 video. I got to be honest with you, this is probably one of the big chapters in in integrated 2 this year, kind of where it all comes together on the parabola shape or quadratics that we've dealt with so much already. So this handout, I think you should kind of keep handy and understand what it is and how it works. And I just want to speak to that a little bit and kind of where we should already know, what we should already have down, and what we're gonna actually do later in this chapter. So if we start in standard form, y equals ax squared plus bx plus c, it would be an example would be something like y equals x squared plus 6x plus 8. And this is a very simple example just because I really want you to see how this worksheet works and not focus so much on the math of it. At this point, we know that we can figure out the y-intercept when we're in standard form just by plugging in 0 for x. That all disappears, so y would equal 8. So our y-intercept is 0, 8. And we also know that we can easily get the axis of symmetry from this form. It's a negative b over 2a. So I'm going to put in negative 6 divided by 2 times 1, and I'm going to get negative 3. So I know that my axis of symmetry, remember that axis of symmetry is negative 3. That's where if I fold this parabola in half, it will be on the line x equals negative 3. When we go from standard form to factored form, we do something called factoring, and we've spent a lot of time on factoring this year. And at this point, we can either use the diamond where we do a times c over b and plug in 8 over 6, and we put it over ax, which is 1x. And in this case, you can see it works out really easily for 4 and 2. Or we could use the quadratic formula, or the quadratic equation formula, which is negative b plus or minus square root of b squared minus 4ac, all of it over 2a. So we have these two choices to go from standard form to factored form, and it doesn't matter which one we choose, but once we get into factored form, it looks like this. And in this example, when we factored it, we would get y equals 1 times x plus 4, x plus 2. When we're in this form, it's good to be able to get the x-intercepts. We know if we plug negative 4 in there, it turns into 0, so I get negative 4, 0. And if I plug negative 2 into this one, it turns into 0. So I have 2 x-intercepts. I don't know how much we've discussed this part of it, that we can check the A to see if it opens up, if it's normal, if it's steep, or if it's flat. And if we haven't discussed that much this year, that's fine, because we're going to discuss a lot of that in chapter 9. So that will be one of the things that either is going to be new to us or that we're really going to explore more in depth than we have already. At this point, if I'm in factored form and I want to go back to standard form, we know that we can just use the area model to multiply this, and then we can multiply it by this a out front. So again, I would just use the area model. I would say x plus 4 and x plus 2. I would get x squared, 2x, 4x, and 8. And that would turn into x squared plus 6x plus 8. I would want to multiply it by this a. In this case, it's 1, so nothing's going to change. But if my a was 2, then everything would have doubled. But you see, we're working right back where we were in standard form. So we already know how to get from standard form to factored form. We know how to get from factored form to standard form. When we're in standard form, we know we can get the y-intercept and the axis of symmetry. When we're in factored form, we know that we can get the x-intercepts. And again, I don't know if we've discussed that, but we'll discuss it a lot more. So here's really one of the major pieces of chapter 9. How do we go from standard form to graphing form? And what is graphing form? You'll see that graphing form is good to get the vertex and to determine the A, but what does that mean? We don't really know that yet. Another thing we don't know is how do we complete the square to get from standard form into graphing form? So that's, again, going to be one of the things that we discuss in chapter 9. That's going to be a really crucial component. Once we're in graphing form, honestly, it's very similar to get from graphing form back to standard form, just like it is factored form to standard form. You can see it's a times the area model. It's going to be a times the area model. The only difference is here we now have to add or subtract this number outside. That's the plus k. So we really know how to do that already. So I would say of new stuff that we're looking at, this is really the new stuff, the stuff that's circled. How do we get from standard form? We complete the square. What is that? To graphing form. When we're in graphing form, how do we determine the vertex and what the A is? And again, that A is the same whether it is here or it's here. Quite frankly, we can determine the A here just as easily, so we wouldn't even need to do any of that. The A is the same in all of them. I don't know why I didn't add that there. I feel like there's enough going on in these notes already. So that's an intro to Chapter 9, how the sheet works. Keep it handy and available. And if there's questions on it, make sure you let me know.